Welcome to The Explainer. Today, we've got an absolutely incredible journey ahead of us. We're going to trace the most awe-inspiring chronological chain reaction ever known, literally the building of our cosmos. From that very first spark of creation to the turbulent formation of our own planet, all the way up to the eventual explosion of complex biology, we're looking at the exact steps that brought us here. It's a story of extreme violence, breathtaking beauty, and above all, just relentless transformation. So get comfortable, focus in, and let's unravel the greatest story ever told. Okay, let's dive right into this. 13 billion. That is the staggering scale of the universe's history we're looking at today. I mean, when we talk about cosmic time, human history doesn't even register as a fraction of a blink. To truly grasp how our reality was forged, we have to stretch our minds way back, 13 billion years back, to an era where the universe was completely unrecognizable compared to the starry night skies we're used to seeing today. Section 1. The Age of Stars, the First Suns. We're shifting our narrative scale here, moving from the unimaginably massive, dark void of the macro universe right down to the chaotic and violent birth of the very first suns. To ground ourselves in this immense history, our timeline starts right here, at zero, the Big Bang. But fast forward just 100 million years, and that's when the universe begins to fundamentally change. The Age of Stars truly begins. Out in the vastness of space, dark matter is silently at work. It acts kind of like an invisible guide, slowly steering infant galaxies into massive clusters that span millions of light years across. It's an epic, cosmic dance, and it takes hundreds of millions of years to unfold. And pulling the strings of this entire cosmic dance? Well, that's gravity. You can really think of gravity as the ultimate architect of the early cosmos. Its invisible hand reaches across the dark, pulling immense clouds of gas and dust together. It literally spins billions of stars together into proto-galaxies. And these early galaxies aren't just isolated islands. They're intricately connected by this massive, sprawling cosmic web of gas and dust. The sheer scale of this construction project is simply mind-blowing. As the universe heats up and evolves, it enters this brilliant new epoch. During this peak period of star formation, new suns are being forged at an unbelievable rate, actually over 10 times faster than they are today. In fact, most of the stars that will ever exist in the entire history of the universe formed during this specific window of time. They seeded the dark cosmos with a blazing light that's going to endure for trillions of years into the future. Section 2. The Dark Engine's Black Holes. But you know, where there's incredible creation, there's almost always terrifying destruction. And this beautifully illustrates the ultimate cosmic paradox. We just saw gravity the architect, right? The force that builds wonders and ignites the stars. But here, we meet gravity the destroyer. You see, the exact same force that gives a star its life is the very force that seals its fate. When massive stars reach the end of their lives, gravity collapses them inward with terrifying power, forging them into black holes. And these aren't just any black holes. They grow in number, and some expand to enormous, frankly, incomprehensible sizes, sucking up billions of stars' worth of matter. By doing this, these supermassive black holes become the dark engines at the very hearts of galaxies, actively shaping the fate of billions of suns. They're so powerful that jets of particles erupt from their cores, traveling at nearly the speed of light. Any stars that happen to venture too close to these dark engines, well, they're violently torn apart, completely destroyed by the exact same force of gravity that gave them life in the first place. Section 3. Stellar Rebirth, Death and Life. Yet in the universe, destruction is rarely the end of the story. Instead, it acts as a deeply necessary catalyst. Now, what's really interesting here is the sheer rarity of what makes our existence possible. As you can see, the vast majority of stars in the universe are small, and 99% of them will just slowly fade away quietly into the dark. But that tiny 1% slice, those are stars with enough mass to undergo a catastrophic collapse and violently explode as supernovas, and that 1% changes absolutely everything. When these massive stars violently explode, they aren't just destroying themselves. Throughout their lifetimes, they were busy cooking up heavy elements deep inside their stellar cores. So, in their explosive deaths, they expel all of those precious heavy elements outward into the void. They are literally seeding empty space with the fundamental ingredients for life. From the ashes of these destroyed stars, a brand new generation of planets and stars arises, rich in heavy metals. It's this beautiful, endless cycle of stellar death and rebirth that perfectly sets the stage for biology. Section 4. The Birth of Earth, a Battered Planet. Which brings the story right to our own cosmic neighborhood. We're zooming in spatially here, moving from that grand, sweeping cosmic web to the quiet, dusty outskirts of the Milky Way galaxy. And here is the exact step-by-step chain reaction that created our home. Picture a cloud of cosmic gas and dust just hanging quietly in the dark. Suddenly, a shockwave from a nearby supernova slams into it, triggering the collapse of the cloud. Just like before, gravity takes over. It pulls all the spinning material together, superheating the gas and dust until it actually ignites. From this intense spinning chaos, a new star is born, our sun, along with a battered young planet we now call Earth. But do not picture a lush blue marble just yet. The early Earth was a nightmare. I mean, it was a molten hell constantly bombarded by aggressive asteroid impacts. The atmosphere was completely unbreathable, choked thick with toxic fumes, and literally pouring down acid rain. It was a chaotic, incredibly hostile environment that seemed utterly incapable of supporting the delicate biology that was about to emerge. Section 5. The Rise of Life Beneath the Waves. Yet, in the midst of that violent hellscape, a miracle was brewing. To find it, we have to leave the fiery surface and dive deep, deep beneath the turbulent waves of the early oceans. Anchoring ourselves at the formation of the molten Earth, we look deep underwater. Down there, cracks in the ocean floor begin venting intense heat and precious minerals directly into the water. This unique environment fuels complex chemistry in the dark depths. And over vast stretches of time, this deep-sea chemistry miraculously brings the very first cells to life. So the crucial point here is just how long this next phase lasted. For an astounding 3 billion years, the entire planet belonged solely to microbes. Really think about that immense stretch of time. It was an absolute empire, completely invisible to the naked eye. For billions of years, microscopic life ruled a world of oceans and rock, long before anything more complex ever took shape. But this invisible empire eventually sparked its own chain reaction. Some of these microbes began to feed off of sunlight itself, and as a byproduct, they started expelling massive amounts of a gas that at the time was highly disruptive: oxygen. This huge influx of toxic oxygen triggered a massive climate shift, essentially plunging the Earth into a global ice age. But here's the amazing part. As that global ice age eventually receded, evolution didn't just recover, it accelerated. By harnessing this newfound, highly reactive oxygen, life gained access to vastly more energy. This paved the way for brand new, advanced forms of life to finally emerge. Let's move forward and see how this builds to a magnificent climax. The source material captures this beautifully, stating, after remaining single-celled for billions of years, some cells begin to unite. And as the last global ice age fades, life explodes. That immense, unseen empire of microbes finally crosses the threshold into complex, multicellular organisms, setting off an explosion of biology that fundamentally transforms the face of the entire planet. We've traced an unbroken chain of events today, from a spark in the dark, to a cosmic web spun by gravity, to massive stars dying in spectacular supernovas just to seed the universe with heavy elements. Those elements formed a molten, toxic rock that eventually, over billions of years, blossomed into a thriving world of complex life. When you look at the sheer, unlikely sequence of this 13 billion-year chain reaction, you really have to ask yourself, what will the next chapter of this evolution look like? Thank you so much for joining me on this explainer today. Keep looking up and never stop.